Today we will talk about water cooled chillers. Okay, it is similar to whatever we have discussed so far in the air cooled chiller portion. like as I said, you have to find out the heat, total heat, right, from the building, and based on the total heat, you have to evaluate what is the system you are going basically. Okay, whether you can go with the DX system, or you can go with VRF system, or you can go with the air cooled chiller, or you can go with the water cooled chiller. It is basically depends upon the capacity. Okay, what you are going to arrive for the building load. You clear, right?
Are you sharing your screen yet? No, not
Yeah,
yet.
I will share the screen as well.
All right,
Uh,
cool. Yeah, but what he said is right. Yes, we
yeah,
took
see what I'm
total.
saying. Basically, whenever you do the heat load calculations, okay, from
Hmm,
there you will start. Basically, you will decide whether which system you are basically you are going, right.
hmm, hmm,
Say for example, I will tell you in example. Okay, there are many projects. Okay, depends upon the project you will decide. Okay, assume that you have
yeah.
a it's a large project, but you have a building at different location. You understand? For
Mm-hmm,
example, if you see one for say for example one workshop or some kind of things. Okay, you have a the plot limit may be bigger. Okay, for the particular project. But say for example you
mm-hmm,
have a you can say that as an example you have a security room one location. Okay, then you can say
hmm.
that say for example if it is a workshop, assume that the material collection area will be in one location. Okay, the material delivery in one location, something like that, different location. You have a different
Hmm.
buildings. Okay, maybe
Yes, yes.
it's the area is maybe different. Maybe the area, the building load may be much higher. Say for example you have a 15 20 buildings, assume like that.
Hmm.
Okay, so
Yeah,
in that,
smaller 15,
yeah,
20
20
smaller
buildings,
buildings which are
in the
like
20,
yeah.
yeah, correct. So if you have a 20 buildings, so say for example, maybe the heat load will be approximate, say for example 100 kilowatt or 150 kilowatt, right?
Hmm, hmm.
Okay, but if the buildings are very nearby, then you can go with the VRF system, right?
Yeah, yeah, okay.
Okay,
But
if the
then
buildings
even
are
over there
separate,
also there is the factor of the horizontal length and the vertical length of the refrigerant piping that comes
yeah,
into play,
refrigerant
right?
pipe, yes, yes. See, I will tell you
Yeah.
when very simple. You have a different manufacturers. If you
Hmm,
go with the LG, if you go with the Panasonic, okay, if you go
hmm.
with say for example, uh, there is a Daikin,
Daikin, yeah.
Daikin is there.
Hmm.
Okay, then you can talk
Yeah,
about
yeah.
like a Mekker. They are also manufacture VF system. So if each and
Hmm,
every manufacturer they have a standard procedure. Okay, for the installation of fan call unit, which is called indoor unit, and also there is outdoor unit, right? Okay,
yeah,
so there is a vertical distance and also there is a horizontal distance.
yeah,
There is a
yeah.
limitation is there. Okay,
Hmm, hmm, hmm,
uh,
hmm.
I am not sure whether I have shared with you this information last time. No. 1 minute. I have this
Yeah.
information in my PC. Let me.
Okay, okay.
Yeah, because I was discussing the same question. Somebody asked me in the last week as well, so I was explaining to them. Okay, just give me 1 minute. I can able to.
Sure, sure,
Yeah.
sure. No, but basically, what you were trying to say was typically, if we were not, if we didn't have any sort of chilled water option, we would typically have individual VRF units serving that particular individual building, right?
Yeah, individual building. Yes, yes.
Yeah, yeah. So each individual building will have its own individual, if like ventilation and individual cooling in itself, like supplied through a VRF system, basically.
Yeah, that is what you can basically you can decide. Depends upon the load. Okay, whether you can go with
Hmm,
the VRF system or you can go with the
hmm,
DX system. Okay, see, it is not
hmm,
only
hmm,
one factor that you will just decide VRF or you will decide DX system. Okay, you have to see many aspects. Like say for example, you have a building in different location. Okay, you cannot have a
yeah.
VRF system, right? Because you cannot install one VRF here and another VRF at different location. Then you cannot run the refrigerant pipe from one building to another building, which will increase
No,
the
you
cost,
can't have.
right?
Yeah, yeah, yeah,
Yeah,
yeah, yeah.
yeah. Even though if you go with the VRF system, maybe in operation wise it is cheaper, but when you talk about space wise, it is not suitable. So these are the factors. Okay. Sometime if you
Hmm,
go with the air cooled chiller, okay, say for example, sometime, okay, you can able to compare VRF system and also water cooled chiller. Assume that you have a capacity of say for example like a 1,000 kilowatt. Okay, correct, 1,000
okay.
kilowatt. Okay, so if you go with the VRF system, okay, one outdoor unit as a maximum, you can go with like some they call it as a 80 HP. Okay, if you go with the
Okay,
I can open one of the manufacturer guideline. You
sure,
can see
sure.
here, this is from Daikin. Okay, if you go further
Mm-hmm.
down, uh, there are some questions is clarified here. Okay,
Yeah.
see, this is the key point for selection. Okay, and
Mm-hmm.
you can see that there are some different capacities. Okay, this is the indoor unit sizing. Okay, you can see here there is a limitation. You can see the piping limitation as a vertical drop between IDU from one indoor unit. Its IDU is nothing but indoor unit.
The
Okay,
indoor
from
unit to indoor unit.
from one indoor unit to another unit, you have a restriction. Okay, for if it is air cooled,
Yeah.
you have also water cooled also available. Water cooled means what? You have a outdoor unit, right?
Mm-hmm.
VR system, you have outdoor unit, correct? That outdoor
Yes.
unit is cooled by air and also water. Same like a chiller.
Oh, okay.
So that system also available with some of the manufacturers. Okay, so if you see that the capacity of the outdoor unit, say for example, it is like 100 kilowatt or 120 kilowatt, the outdoor machine, okay, and where you can utilize like a water cooling. Say for example, where the water cooling is basically applicable, where you have a water availability is more, right?
Availability is available. Yeah.
Available, yeah. So that in that cases you can go with the even water cooled as well to cool the condenser, the wear of condenser. Okay, so you can see here vertical riser, there is a limitation from first joint, from linear length, total network, what is the limitation, everything is given here.
Okay.
Okay, so this is a
So
guideline.
I'll go through
This also I will be sharing with you as well. And if you go further, this is the circuit. You can say this is your outdoor unit. You can say that multiple outdoor unit can be connected with multiple indoor unit, right? Okay, and also the indoor unit will be looped to the controller. You can say that there is a common controller.
Got it.
Okay, so this is the system, and basically the decision how you make, whether you go with VRF system or you go with the DX system or you go with the chiller, air cooled chiller, or you go with say for example water cooled chiller, depends upon the capacity, and also there are many factors. You will consider what is the cost. Okay, that is one of the factor, and also you will consider what is the space availability. Okay, and what is the architectural space, like feasibility. Say for example, you have a building, one location, another location, how you are going to run the either chilled water pipe, or you are going to run the VRF system, or go with the separate DX, which is more easier for the operation wise. Okay, and space availability, maintenance, everything. You will see that one, then you will decide. Okay, no one say that you have to go with the VRF system. No one will say that you go with the air cooled chiller. Okay, no one will say that you go with the water cooled chiller. Based on the project, you can decide which system you can go based on the different points which I shared with you last time. Okay, space availability, number of chillers, elevation. Okay, what is the COP, and what is the size of the equipment. Okay, and say for example, you may there is a building. Okay, maybe you want to go with say for example air cooled chiller. Okay, when you calculate the total building load, maybe you have a 4 or 5 air cooled chiller, but there is no space to keep it inside in the roof or in the ground level, or when you keep the in the roof level, your structural load cannot withstand to keep the chiller,
bear
right?
the loads.
So that is also one of the factor. We have to see, then we have to decide. Okay, so say for example, if you cannot keep the chiller, then you have option to go with the VRF system, where you have a small outdoor, right? So like that is
smaller, but we will be just compiling like outdoor units together. And then we'll be just basically doing a distribution accordingly.
See, basically, what you are calculating is the heat, right? The heat.
Yes.
The heat from lighting, envelope. So you can go with any machine, which will be the same. You can say that same principle. Okay, maybe the efficiency will vary. Efficiency may vary, but same principle. You cannot say that. Somebody used to ask me in the HAP calculation. Okay, when there is an option to select indoor unit, chilled water unit, or say for example DX unit, or say for example some other unit. It is say that if you go with any machine, okay, it is the same principle. You are going to cool that particular space, right? So whatever the load, it is a load. It's a heat load. So you can go with any machine which can cool that particular room, right?
Yes, but that was a confusion that I also used to have. But then at that point, when you choose your system, do you just choose like typical terminal units and close it off, or within
no, see, no. Normally, what we do, basically, I will tell you, there is some option in the HAP. If it is a chilled water, go with the chilled water system, because you have to enter the delta T.
Chilled water supply and return.
Delta T. Okay, when you go with the VRF system or split unit, you have to select the outdoor unit, right? The ambient temperature. The ambient temperature you have to enter. There is an option to enter the ambient temperature. And also there is an option to enter the refrigerant pipeline. Okay.
But is this the package rooftop units that you're talking about, or
Yeah. This packaged rooftop unit to your length of the uh, unit, the length of the pipe between the indoor unit and outdoor unit. Okay, so that also they will
okay.
lost, but it is not necessary to enter the pipe length because you have to calculate the capacity only. But when you go with the manufacturer selection, you can tell them that what is the distance, maximum distance from one location to another location, then they can select the proper unit.
Okay, no, because I'm just going through the systems here. I just have a app open with me because I was just looking through in
Yeah,
that
you can,
you have
go very simple. You go with the chilled water system. There is a chilled water
mhm,
option. There is a split unit
yeah.
option available for indoor and outdoor. There is a VRF system also available. When you have a multiple space, you can able to enter multiple spaces.
I don't know. Maybe in the version, are you sure we have a dedicated version for VRF or
No, there is no
for,
dedicated VRF. If you go
yeah,
with the, I'm not sure. There is a terminal unit. I think there is a uh, option
terminal
available.
units is like there's terminal
Yeah.
units, but terminal units is not basically VRF, right? If I'm not wrong.
Uh, no, I think if you go with that option, if it is open, can you check that there is option
Yeah,
to enter the multiple spaces?
option two. Okay, can I quickly share my screen if that's okay?
Let me 1 minute. I will try to open from my system.
Because the thing is, I think it's better we do it from your screen because I'm just looking at the spaces common data. It still looks the same to me, honestly. So,
Yeah, here you have the right variable refrigerant flow.
okay, I don't know. Maybe in my version, I don't have it. I think it's a my issue. Maybe I'm not sure. I
Mm-hmm.
don't know. I'm just trying to
Okay,
pick
so
this up.
here if you go there is a number of zones.
Yeah.
Like you have a multiple spaces, right? So that say
Mm,
for example, if you enter 12, then if you go to zone
mm.
component here, you can enter 12 spaces, right?
Okay. Yeah. Okay. And yeah, now I understand. So basically, you're trying to say that one zone basically means one outdoor unit that
Yeah,
serves this
no,
many
one indoor
spaces.
unit. One if you have a 12 spaces, that means you can put 12
Okay. Yeah.
outdoor,
Yeah.
12 indoor
Yeah.
units.
12 indoor units, basically. Yeah. Got it.
Yeah,
Got it.
clear,
Yeah.
right?
Yeah.
Okay, so now if you go to the water cooled chiller portion, like if you continue from the air cooled last week, it is the same only. Okay, so say like what I said last week, like there are two type of cooling. Okay, to cool the
Yeah.
condenser basically. Okay, either you cool by air or cool by water, right?
Mm. Mm-hmm.
So that is
Yes.
called
Yes.
air cooled chiller, and you have a water cooled chiller. So the water cooled
Yeah.
chiller normally you will cool by means of water. Okay, that is called it as a condenser water, right? Because it's a
Yeah.
condenser water, right? You are cooling the condenser, so it's called a condensate circuit. Okay,
Okay.
okay. Now if you go to this particular one chiller, okay, I can open one of the chiller selection as well. Okay, and if you go
Mm-hmm.
to this is the chiller picture you can say, right? So
Mm-hmm.
normally
Mm-hmm.
you have seen that air cooled chiller, right?
Yeah. I've seen the air cooled chiller. Yeah.
Okay, now this is the water cooled chiller where you can see that there is a evaporator and also there is a condenser, right? So this is the one heat
Okay.
exchanger and this is the one heat exchanger. So normally
Mm.
the chilled water, this is the inlet and this will be
Yeah.
outlet, right?
Okay.
Okay, and similarly if you see here, this is the cooling water inlet and cooling water outlet here. You can say that
Mm.
outlet here, right?
Mm-mm. So basically, when we say the cooling water inlet would be the same temperature as the chilled water inlet, right? No,
No,
you're
no,
saying
no.
it.
See, basically,
Mm.
I will tell you something. Uh,
Mm-hmm.
this is the cooling tower side, like condensate water, right?
That's the
Okay. Then this
yeah.
is the building side, right? This is the building
Yes,
side. So
yes,
the
yes.
evaporator and the condenser, right?
Correct.
Okay.
Yeah.
Normally, when you see this is the refrigerant cycle, you can say this is the refrigerant cycle. I will say like that. So this is nothing but centrifugal compressor, right? You can say that
Mm-hmm.
centrifugal
Okay.
compressor, right? So this centrifugal
Okay.
compressor is a part of the refrigerant cycle. Okay, so
Okay.
where you have a
Mm.
compressor, expansion vessel, condenser, and evaporator, right?
Okay.
So there is a refrigerant circuit here. Okay, where
Yes.
this refrigerant will cool the water, and that particular
Mm-hmm.
refrigerant will dissipate the heat but through the condenser. Okay, so that condenser will take the water from here, right? So normally you
Yeah.
can
So
call, yeah.
so what I was trying to say was the temperature in the cooling water, whatever water that we receive into the outlet will match with the cooling water that comes back to the condenser is similar to the temperature we have in the chilled water, or is it going to be higher or lower? That's what I
No, it will
was
be higher.
confused.
So cooling
It'll be
water will
higher,
be
right? Yeah.
normally I will say that it is like a 42 or
Hmm.
something like that. Okay. Also, I can
Okay,
open one
okay,
of the
okay.
schematic diagram for your reference.
Yeah.
This is one of my previous project. Okay.
Mm-hmm.
Mm, sorry, give me a moment. I will try to open.
Yeah, sure, sure. No worries. No worries.
Because in UAE you don't do normally the water cooled chiller. It's very rare, very rare.
Yeah, I
So,
know, I
yeah,
understand.
actually in
Generally,
my
yeah.
I have worked only one project for the
Mm.
like since 2008 I came to UAE. I worked only one project with the cooling tower.
Mm,
One project or two project, I think. Not sure.
okay.
I have one schematic. In that schematic, it will explain
Yeah.
everything basically. Trying to look at that schematic. Yeah, maybe it is in a cooling tower portion. Yeah, it's here schematic. So if you see, this is one of my previous project basically. Okay,
Mm-hmm.
and if you see, this is the cooling tower, right? You can say there is a cooling tower 1, cooling tower 2. Okay,
Yeah.
you can see the water temperature from the condenser. Okay, like around 42 degrees Celsius. So that will go to
Mm-hmm.
the cooling tower, then it will cool, then it will come back around 34 degrees Celsius. Okay, to the chiller.
Okay, okay.
So you can
So
say here,
the
this is a chiller, 34 degrees Celsius, and it will leave at 42 degrees Celsius. This is a standard chiller. Okay, if you go to any of
mm-hmm.
the standard building for comfort cooling, this is the temperature. Okay,
Okay.
you can see very clearly that the 5.6 degree will be leaving from the chiller. Okay, going to the building. Then after absorb all the heat, it will come back at 14.4 degrees Celsius. This is the
Yes.
evaporator,
Okay. Yeah. Yeah.
and
Okay. 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 Okay.
this is the condenser.
That is
Okay,
the condenser. Yeah.
so it will leave at 42 degrees Celsius because after absorb all the heat from the refrigerant circuit. Okay,
Mm-hmm.
then it will go to the
Okay.
cooling
Okay.
tower. It will
Okay.
cool down.
Mm.
It will come back at 34 degrees Celsius.
So, irrespective of air cooled or water cooled chiller, there is always the refrigerant portion that is involved in the chiller,
Yes,
irrespective of air cooled or
yes,
water cooled.
yes, yes,
It's
correct.
just that when in the case of air, whatever temperature that is being rejected from the refrigerant, it just goes out and gets rejected via air. And whereas for the water case, we have the water that basically does all of the rejecting the absorbing the heat and rejecting it outside. Correct?
Yes, correct. Only here, what is the difference
Okay.
if you are using water and air? The efficiency is
Hmm.
much higher for the water, right? Because it is a material that it can cool the refrigerant, right? Its air is nothing but
Yeah.
it's like a, it's like a, its air is air, okay? So the
Hmm.
cooling
Hmm.
capacity, the cooling efficiency of the air is much lesser compared with
Much.
water. So that is why
What?
when you go with, say for example, assume that if you are going for one projector, okay, you have a
Mm-hmm,
thousand.
mm-hmm.
Assume I'm saying something some assumption. Say for example, you have
Yeah.
a 5,000 kilowatt heat load, okay. So what you can do if you are going with air cooled chiller, you have to go with 1,000 kilowatt into 5 numbers, correct? As an assumption.
Yes.
Okay,
Yes.
but whereas if you want to go with a water cooled chiller, you can just go with one water cooled chiller. some capacity. Say for example, if you go to this particular sheet, can you see what is the capacity of the water cooled chiller? Cooling tower 1880 kilowatt. Sorry,
Yeah.
tonnage, right?
Refrigerant done. Yeah.
So if you talk about multiply by 3.56, it will be around say for example 1880 multiplied by 3.56,
6,600
so
kilowatt.
it is around 6700
Kilowatt. Yeah.
kilowatt. Okay, so if you go with
Yeah.
1 kilowatt, one chiller, and you can also see the size. What is the size? Say for example, the length of the chiller is approximate 7 meter. Okay, and if you go with the width, say for example, it is like 1062, 400, and 400. Say for example 2 meter, right? Sorry, 1000.
No, 600 plus 842, right? So that
Yeah,
means
yeah,
around
yeah.
like 900. Yeah,
It
if
will be
we put it in
3000,
50,
right?
yeah,
3000 you
3000
can say.
basically. Yeah, worst
Okay.
case scenario. Yeah.
Yeah, so that means you can say that like I will round off just for our calculation purpose. 6200 by 3100, right?
Yeah. Yeah.
Okay, so that is like a rectangle. Okay, but whereas if you
Yes.
go with the air cooled chiller, okay, this is assume that this is the size 3100 or 6200 by 3100. Whereas if you go with the
Yeah.
water air cooled chiller, you have to go with at least for 1000 kilowatt chiller, you have around 8 meter or 9 meter length. Okay, and this will be approximate 2.4 meter, right?
2.4 meter. Yeah, but
Okay.
then this would be by number of 5 numbers next to each other. That means your
Yeah.
entire space is
Yes.
being taken up, basically.
Yeah, that is also one more thing. You should have a distance between two air cooled chiller. There should be some distance because it is
Yes,
air,
yes,
right?
that will be.
So
Yeah, yeah.
that hot air should not recycle. But whereas if you go with water cooled chiller, you don't have any space issues. You can keep next to air cooled chiller very nearby. Only just you have to give the space for the maintenance.
Maintenance only.
Okay, but whereas if you go with air cooled chiller, you have to keep at least a minimum. If you go with the manufacturer, they will tell you that you should keep with a 3 meter distance between one chiller to another chiller. So you are
It should
consuming
not even be
space.
the width, but it would not be even not the dimension of width of the unit like how we typically do for indoor units. No, it would be much more than that, right?
Sorry, I didn't get you. You mean the distance
Typically-
between two air cooled chiller?
No. Well, yeah, the distance between two air cooled chillers. You said it is at least 3 meters, right?
Yeah, correct.
Based on the manufacturer, it can change. I understand, but typically, if you remember, when we do our HUs or say if we are placing our HUs within the plant room, it would generally be the width of the unit plus another 400 or 600 that
That is for maintenance. See, when you talk about FHU, FHU is different. It is for only for maintenance. Okay.
Yes.
But when you go with the chiller, it's not only for the maintenance, it is also for the air circulation. Because whenever you have a hot air, it should not come into the, again, it should not recycle, right? So whatever the hot air from the condenser, it should go on the top of the atmosphere. Okay, it should not come back again, and it should not affect the chiller condenser, right?
Yeah, but this is the air cooled chillers, right? Typical 3
air cooled chiller.
meters.
Of course, yes.
Even air cooled, yeah.
Yeah, air cooled chiller. Whenever you discharge the heat from the condenser discharge, after that the same air should not come again as an inlet of the condenser again, right? So that is why they keep the distance between two chiller, and then they will give the space below the chiller so that there will be proper air circulation. So when you talk about air cooled chiller, it consumes a lot of spaces. Whereas when you compare with air cooled chiller, water cooled chiller, okay, but water cooled chiller, the maintenance is very you are increasing the maintenance because you have a water cooled chiller, then you have a cooling tower, then you have a condenser pump, right? Then you will be having a chilled water treatment. So that means when you go with air cooled chiller, it's simple air cooled chiller. You have only the number of chiller is much higher, and it is very simple system. Okay, but whereas if you go with the cooling tower,
components are much like you said, the number of components are much less in comparison with the water cooled chiller. Right?
Water cooled chiller, basically. Yes.
Yeah. Okay, but then, but still, I mean, like you said, for example, if in a water cooled chiller, you said there is the chiller itself first, and then there's the cooling tower. There's you said the different apparatus for the condenser water, for the chemical treatment, and everything as well.
You can see
all
here. All of that will consume spaces basically.
Yeah, but like I said, the chillers, all of this should be placed outside. They can't be placed inside the particular. For example, air cooled chillers will have to be placed outside.
But water cooled chiller you can keep it inside.
We can keep it inside still, right?
Okay. Yes. Water cooled chiller you can normally if you go to so I have worked one of the project where my water cooled chiller was in the basement. Okay, And in the ground floor level, like a ground floor exposed area, they kept the cooling tower.
Cooling tower. Okay. No, I just wanted to understand. Yeah.
Yeah,
Yeah.
and normally why they select the basement, because the weight of the chiller is much higher, so you cannot keep it on the upper roof or roof, something like that, because the weight of the chiller will be very high. If you go to the data
Base
sheet, okay, I'm not
for the
sure
water
whether,
cooled chillers typically,
yeah,
though,
yeah,
right?
water cooled chiller. Normally they will choose like the lowest floor, okay, whether it's the ground floor or if you have a basement, they will try to go to the basement because it is having a lot of weight. Okay, I'm not sure whether the weight is here, but it's very heavy. Okay, compared to air cooled chiller.
Compared to air cooled chiller.
Clear, right?
Yeah.
Yeah, I think it is here. You can see that operating weight. You can see that around 30,000 kg, right?
Okay.
30,000 kg.
1 ton is the 1 ton is 1,000 kgs, right?
Yeah, 1,000 kg. So you can say the 30 ton.
30 ton.
Okay. Yeah.
Oh,
So if you go with air cooled chiller, normally air cooled chiller can be like 8,000, 9,000 kg, 9,000 kg. Okay, so you can say that the weight also almost 3 times, right? So this will increase the structural load basically if you are going to the roof or something, because see, for example, your footprint is only this much, right? So just see that how much heavy your structure should be, right? So if you talk about kg per square meter something, so this is much higher. So that is
for water
one
cooled
of,
chillers in comparison to air cooled chillers.
yeah, that is one of the factor. But remaining portion almost it will be like same. Okay, so when you consider your say for example here there is no ambient temperature, no need to consider, and there is no need of elevation, for example, right? But the elevation matter when you do the cooling tower, for example, right? And yeah, and here there is a space constraint. Yeah.
Sorry. What you mean to say is for water cooled chillers, you don't have to consider the elevation, right? And the
yeah, because it's a water, right? It's not air. It's not air cooled.
Okay, yeah. No. That's why I'm asking. But for example, you said the ambient temperature is only in the scenario where you have your chiller inside the building, right?
No, where the scenario outside where the chiller is outside the building.
No, but that is for air cooled chiller only. Even for water cooled chillers, because
yeah, water cooled chiller you don't consider ambient. You don't require to consider
that's
ambient.
what I'm asking. You don't consider any of these components such as your altitude or elevation and your ambient temperature as well.
Yes. Okay, that is one of the factor, and also then other parameters like you will consider what is the chilled water in, what is the chilled water outside, and what is the what is the flow rate, right? If you go to the, remember there is an equation in our the equation folder. There is a GPM for evaporator and GPM for condenser, right?
Yeah. Okay, so that 500 into sorry.
Yeah. TR multiplied by 24 divided by delta T. The other one TR multiplied by 30 by delta T. Okay.
Yeah.
Okay, so that is the same equation. Other parameters, whatever you do, the selection, everything is same. So here also you do.
So even typically we say for air cooled chillers, the temperatures would be 6 and 12. You would still be able to hit the same 6 and 12 in water cooled chillers as well.
Yeah, water cooled also. Yes. See, for example,
yes, it is okay.
If you talk about this 58, if you convert into Celsius, okay, you will get the same thing. It is the comfort cooling. Everything will be the same. Okay, and you can talk about the flow rate. Okay, the flow rate calculation here, and for the condensate calculation here, right? So this is the same. You can calculate.
This is one thing I wanted to ask you. When we say the flow difference that we see 2820 and 3644 between evaporator and condenser, why do we have that difference in the flow rate?
Yeah, this is what you asked me last time. I have to search that. There is one equation is there. Okay. Okay, because I will give you the proper statement. Okay.
No worries. But it's just that I think maybe I wasn't sure if I asked you the question or not, but I just wanted to make sure if I had asked it or not. That's all.
Yes.
But there is that difference there. Even I checked in the other selections for air cooled chillers.
Yeah, if you see the equation, normally GPM equal to TR multiplied by 24 divided by delta T. Okay. And if you
Yeah.
go to condenser side, you have a TR multiplied by 30 divided by delta T.
30.
This
That's the
equation,
difference
there,
only, just
yeah,
because
there is a
the
difference.
factors are different. Yeah.
That is a
Okay.
difference. But why that difference? I will give you the proper answer. Okay.
Sure.
I have one
No worries.
document. I will check it and tell you. Okay.
No worries.
And
Yeah.
yeah, and this is similarly the same thing. IPLV value. How
The
you calculate
IPIV values
the
that we
same thing? You
said.
have 100 percentage. You have refrigerant. You have input power. Same thing. You will calculate the COP, as I said, right? The same thing you will do the calculations.
Yeah.
Other all parameters. It is very similar to your air cooled chiller.
Selection.
Okay, but only when you see that when you have a water cooled chiller, you can say that there is a building side. You have a same what we have seen last time. Okay, you have a chiller, then you will be having a pump, then you have a pressurization unit, you have a condensate chemical treatment. Okay, so this is then you have a building side. Okay, you have a FHU or AHU or FCU, whatever it is. Okay, but in case if you have a water cooled chiller, then you have another circuit called condensate water circuit. Okay, which you have a the water cooled chiller condenser side. Then you have a cooling tower. Then again you have a condenser water pump. Okay, then you will be having a chilled water treatment. Okay, and here there is no pressurization unit because it is an open system, right? You cannot have a pressurization unit in this system because this is an open loop and this is a closed loop, right?
Okay. So the reason for pressurization unit is only is to balance the pressurization between the
pressure inside
loops,
inside the closed loop. Yes.
Okay.
Okay.
One
so
second, please.
Yeah.
Yeah, I just wanted to take note of it because I always had this question because for example, in the drawings that we have prepared maybe for a water cooled chiller, you wouldn't have the same pressurization unit. So I just wanted to know what is the reason.
Yeah. Clear, right?
Yeah.
Okay. Okay. Then this is a circuit in general.
When you mean open loop system, it's just because the fact that we have the heat rejection happening. That's where you're trying to say the.
No, it's not like that. See, when you have a closed system, that means the water is within the piping, right? It is not exposed to atmosphere, basically.
But if that's the case, the buildings, for example, even the building side, it is a closed system, right? Because it's going, whatever water that's going around is still coming back, right?
Yeah, it is a closed system. That's what I'm saying. I'm talking about building side only. Okay, it is not exposed to the atmosphere.
Then you said in the in the
but
other
when you
side,
talk about cooling tower side, it is exposed to atmosphere. So what will happen? This water will go to the cooling tower and it will spray on the top of the. There will be nozzle on the top of the cooling tower. Then it will spray the water. Okay, because it is like same like shower.
Okay.
It is same like shower.
Okay, your reasoning for calling it an open system is because of the fact that if, for example, if I could, I don't know if I can request control, say within the cooling tower, if the pipework was closed, like instead of open, you would have still called it a closed system, basically, right? But in the cooling tower, that is not how it works because by the time it reaches the cooling tower, it basically sprays down, right?
Sprays down. So that means here there is a break, right? There is a break.
Yeah. Hence the open system, basically.
So it is an open system. Like that means there is a outside atmospheric air will try to come inside the inside. There is a fan as well for the cooling tower. So when the fan runs, it will take the air from outside to cool the water.
Yeah.
Okay, so that water will be getting cooled from 42 degrees Celsius to 34 degrees Celsius.
To 34 degrees Celsius.
So then that water will be going to the cooling the condenser side of the chiller again by means of condenser water pump. The condenser water pump basically it will circulate the water from cooling tower to the chiller. Then it will take it to the cooling tower again.
Yeah. Okay.
Clear?
Yeah, I'm sort of clear. Yes. So,
okay.
But can I ask you, in the drawing right now, you've got, okay, that's because you have two cooling towers. That's why you have got two sets of condenser pumps, right?
Yeah, you can say like that as well. Yes. Remember last time when I said it is basically for one cooling tower, you can consider like one condenser water pump. Okay, so that it can, and also you can have a multiple pump as well. No problem in this side. Okay, this is not like a chiller.
Yeah,
Yeah.
but then my I just have a question here. Say for example, your idea is the fact that for one so for each cooling tower you have like three pumps in. So you've got one. So is it
Two
how
duty,
does
one
it work?
standby.
Two duty and one standby, right?
Yeah.
But what is the reasoning for the two duty? For example, can I not just make it one duty and one standby?
Yeah, you can make it, no problem. But why you make a multiple two duty? Say, for example, I will tell you something. You have 100 liter per second water, right?
Yes, yes.
Okay. Now, if in your project, if you have 100 liter per second, so what you can do,
Mm-hmm.
you can go with either 100 plus 100, or you can go with the
Mm-hmm.
50, 50, 50, right?
Yeah, okay,
Okay. When
okay.
you spend
Like you mean to
100
say
plus
from an
100,
efficiency standpoint of view and not
yeah,
actually overrunning the pump basically.
yeah,
That's what
basically,
you're
say for
trying to say,
example,
right?
no, that is one of the one point of view is a cost. Say for example, if you go
Okay.
with 100 liter per second pump for 100 rupees,
Mm,
for example, okay, 100 dirham or
mm,
something like that.
mm,
And if you go
mm,
with another
mm,
100 as a standby, then you have to spend another
mm.
100 dirham, right? So you are spending 200 dirham.
Yeah, yeah, okay,
If you go
200.
with
Whereas
50
for
plus 50
50,
plus
you're
50, you
not.
will spend only 150. So that is also one of
Yeah,
the
yeah.
important factor. Okay, that is why
Okay,
you go with
okay.
the two duty, one standby. Okay,
Mm,
and
mm,
if you go
mm.
with, you can go with the multiple duty and multiple duty pumps and with one standby pumps. No problem. Okay, there is
So
no, there is a,
there is
there
no
is just
right
our
way or wrong way
decision.
of doing it,
Yeah,
basically.
that is our decision only. Okay.
Okay. Mm-hmm, mm-hmm. Okay. Now, because
But when you
for
go with
example,
the
now, yeah.
primary side, say for example, you have a chilled water pump for the chiller. So that particular chiller you should have a primary pump. For each chiller, you should have one primary chiller, because you are going to circulate the water to the chiller, right? So
Mm-hmm,
that you should match with the chiller capacity. But whereas here, cooling tower, you are not going to supply the water to the particular cooling tower. Okay, so you have a common system where you can take the average, the common water to the pass through the system. So you can have a multiple pumps.
Oh, okay, you mean to say basically, since it's in a common header, it doesn't matter like how
That
many pumps.
yes, yes, yes. Okay, so that you
Okay.
can decide. You can go with the 10 pumps. So what about your space in the project?
Yeah,
There is a restriction,
that
right?
will.
So
Yeah, there's a
you have to
restrictions.
reduce that number of pumps to match with. Yeah, you can able to hear.